In this lesson, let's learn about the origin of the solar system as proposed by Marquis de Laplace. Our solar system contains the Sun, inner rocky planets, the gas giants, or the outer planets, and other celestial bodies, but how they all formed is something that scientists have debated over time. The nebular theory, also known as Nebular Hypothesis, presents one explanation of how the solar system formed. Laplace proposed the theory in 1796, stating that solar systems originate from vast clouds of gas and dust, known as solar nebula, within interstellar space. There was a huge and hot gaseous nebula in the space and it was rotating in its axis. The nebula was continuously cooling due to loss of heat from its outer surface through the process of radiation. Thus it was continuously reducing in size due to contraction on cooling. Laplace maintained that there was a hot and rotating huge gaseous nebula in the space. There was gradual loss of heat from the outer surface of the nebula through radiation due to circular motion or rotation of the nebula. Thus, gradual loss of heat resulted into the cooling of the outer surface of the nebula. Gradual cooling caused gradual contraction in the size of the nebula. These processes, gradual cooling and contraction, resulted into continuous decrease in the size and volume of the nebula. Thus, reduction in the size and volume of the nebula increased the circular velocity, rotatory motion, of the nebula. As the size of the nebula continued to decrease, the velocity of rotatory motion continued to increase. Thus, the nebula started spinning at very faster speed and consequently the centrifugal force became so great that it exceeded the centripetal force. When this stage was reached, the materials at the equator of the nebula became weightless. Consequently, the outer layer was condensed due to excessive cooling and rotate faster while still cooling and contracting of the central nucleus of the nebula, and thus the outer ring, layer, was separated from the remaining part of the nebula. This separated ring of material known as protoplanetary disk started moving around the nebula. This ring may be compared with the present ring of the Saturn planet. The ring contained materials that made up the planets known as planetesimal objects. Laplace further maintained that the original ring was divided into 9 rings and each ring moved away from the other ring. All the materials of each ring condensed at a point or not in the form of hot gaseous agglomeration. Each such agglomeration was later on cooled and condensed to form planet. Thus, 9 planets were formed from 9 rings and the remaining central nucleus of the nebula became the Sun. Here are some evidence that support nebular hypothesis. Observations of young stars, particularly in regions like the Orion Nebula, have revealed the presence of protoplanetary disks, structures of gas and dust believed to be remnants of the original cloud from which planets form, aligning with the nebular hypothesis. The nebular hypothesis is supported by observations of star formation in other galaxies, where similar nebulae are observed to form around young stars. The chemical composition of the Sun and planets is similar to that of interstellar gas clouds. The Sun, planets, and interstellar gas clouds share a strikingly similar chemical composition, supporting the idea that they all originated from the same solar nebula. Planetary motion follows an ordered pattern, with all planets orbiting in the same direction and roughly within a plane called the ecliptic. Similarly, the satellites of the planets orbit their primary bodies in the same direction as the planets. The distribution of planets reflects their composition. Rocky planets lie closer to the Sun, while gas giants are found farther away. This supports the nebular hypothesis, which suggests that denser materials condensed near the Sun while lighter gases remained farther out. But the hypothesis is criticized on various grounds. Laplace considered that a heated and whirling nebula existed at first, but he did not specify the source of the nebula's beginning. Where did that nebula's heat and motion come from? When calculated mathematically on the basis of the known orbital momentum of the planets, the nebular hypothesis predicts that the Sun must rotate about 50 times more rapidly than it actually does. There is also some doubt that the rings pictured by Laplace would ever condense into planets. What was the reason behind the formation of certain fixed number of planets from the irregular ring? Why did only 9 rings come out from the irregular ring detached from the nebula? Why not more or less than 9 rings? He did not explain the reason behind the formation of only 9 rings, not more or less than 9. The Nebular Hypothesis struggled to explain why the planets, not the Sun, hold the vast majority of the Solar System's angular momentum, around 99%. Mathematically, the theory predicted that the Sun should have a much higher angular momentum, and therefore rotate significantly faster, based on the planet's orbital motion. This theory was rejected when it was learnt that the angular momentum of the Solar System is concentrated in the planets and not in the Sun. Despite all the demerits, the Nebular Hypothesis is the most widely accepted model for the formation of our Solar System. It explains how all of the planets formed in their current orbits, and why they are made of different materials. It also undergoes modifications to help explain the origin of Solar System as more information is being gathered.